Of interconnecting road networks has a significant impact on the way in which road users make their journeys. This video looks at the critical elements that engineers need to consider when designing the road networks for the safe and efficient flow of traffic.
An intersection is where two or more roads meet to provide a means for traffic to change its direction of travel. Here, road users make decisions and take the necessary steps in order to safely and efficiently progress their own journey without interfering with that of other road users. They are expected to make these decisions and manoeuvres based on the road use code of the country in question. For example, in the UK, this is described in the Highway Code. Despite this guidance, intersections have a high potential for accidents to occur. In general, there are two types of intersection. At-grade junctions, for example roundabouts or level crossings, and grade-separated junctions, for example cloverleaf interchanges. A roundabout is a circular intersection in which traffic flows in only one direction around a central island. Adopted by the UK in 1960, the mandatory give-way at entry rule was a significant and important change in the success and use of modern roundabouts. Compared to a priority junction, that is, a junction without traffic control, the roundabout has a number of benefits in capacity and safety enhancement. These include reducing vehicle conflict points, eliminating head-on collisions, and reducing the demand for traffic control. Conflict in the direction of flow often results in the slow movement of traffic, also known as congestion. Therefore, the overall capacity for a road depends significantly on the performance of its intersections. The UK Transport Research Laboratory established the relationships between entry capacity at a roundabout and 6 geometric parameters, based on observations at a number of locations involving 500,000 vehicles. As this animation shows, the entry width value affects the entry capacity for a particular route onto a roundabout. This allows planners to calculate what is known as the ratio of flow to capacity of the route. Effectively, this means that if the value of the ratio of flow to capacity is high, congestion will result. Another form of traffic management used at roundabouts and at junctions is signal control, commonly known as traffic lights. Traffic at signalised intersections is regulated according to time and/or the available space. The primary purpose of traffic control by light signals is to prevent conflict between vehicles. This is done by allocating a certain amount of time and road space to each traffic flow in a safe, efficient and equitable manner. Cycle time, the completion of a whole sequence of stages, determines the length of red and/or green periods and is a main design element in traffic engineering. This example illustrates how each stage in the light sequence manages the flow of traffic as a single-lane road meets a two-way carriageway. Grade-separated junctions are intersections where one road passes over another, with or without ramps to connect them. They are designed to allow traffic to move more freely, with fewer interruptions and at higher speeds. They also provide fewer conflicts between traffic flows, reducing the risk of accidents. However, grade-separated junctions are space-intensive, complicated and costly. This is due to their requirement for large physical structures, such as tunnels, ramps and bridges. In addition, due to their ability to accommodate large traffic volumes, grade-separated junctions contribute significantly to noise and air pollution for nearby residents and businesses. The M25 ring road around London has more than 30 grade-separated junctions, which connect the M25 with radial motorways, for example the M1 and the M40, and trunk roads. In a perfect world, junctions would provide an optimal solution to allow traffic to move swiftly and efficiently between the roads they connect. Unfortunately, vehicle speed and volume, cost, land use restriction, and aesthetic considerations often have competing requirements in a junction design. Due to this, compromise is frequently made to meet the design requirements. However, speed, consistency, and lane balance are critical design considerations. This is the M40-M25 interchange. Note that in this junction design, one cloverleaf-shaped loop is provided for the north and southbound traffic, each to turn right onto the M25. But the east and westbound vehicles will follow a straighter link in order to make the right turn. Both the links are located in the third quadrant. Land use restriction in the first and third quadrants is likely the reason for this layout. The direct links also enable higher speed for right-turning vehicles. This is needed due to high volume of traffic on the M40. However, this required 2 bridges to be built as a result of providing these direct links.
The design of traffic intersections frequently demands a compromise between the ideal solution and what is realistically achievable. A key role for transport professionals is to consider the wide range of influencing factors and to arrive at an optimal solution that balances the needs of road users, residents, and the environment.